This is Sanjay Varkatia. So this is the demo for Financial Detective, the task 2 problem statement. I have committed my code on this Git repo. The Financial Detective is an LLM-powered pipeline that converts your unstructured financial text into strictly pedantic validated knowledge graph. It contains companies, risk factors, dollar amount. I'll walk you through the README first and then explain the design and architecture and show the final output. So the project extracts a knowledge graph from a raw financial text. The graph contains the company's risk factors and dollar amounts, and output is strict pedantic validated JSON with visualization. Right. So financial documents are unstructured and very hard to analyze, right? So manual and regex based extraction is fragile. So our goal is to accurate entity and relationship extraction from this raw financial text. The design highlights which has been considered here is provider agnostic LLM architecture. It swapped between OpenAI, Gemini, and Llama with environment variables with no code change. Factory pattern for extractor selection, automated document chunking, interactive iterative extraction with live updates on the browser, strict schema enforcement through pedantic v2 with extra equal to forbid to reject unexpected fields, no regex LLM only extraction, auto repair invalid relationships, orphan node cleanup, fail fast validations to surface out all errors with messages, right? And your optional confidence score as well as your interactive HTML visualization. So I already explained why LLM over regex, because regex matches patterns, not meanings, right? Financial languages varies widely. There are a lot of variations. LLM understand context and relationships. So no regex is used anywhere in extraction. For example, financial documents are varied phrasing for sample same concepts like revenue of $1.2 billion, reported earning totaling of $1.2 billion, and $1,200 million in net sales. All express similar information but require different regex patterns, and LLM handles all variations naturally. Now I'll walk you through the architecture. This is the pipeline, financial detective pipeline, where I'll input the raw text through input loader. The extractor package will select which type of extractor LLM to be used using a factory pattern. Temperature 0 maintains the deterministic, handles the deterministic way of output. The chunker and merger outputs in the JSON mode. Once the LLM gives an output, the pedantic validator will validate the output as per the schema. Strict validation will be handled, and it then validated PY will auto repair the invalid relationships, removes orphan and meaningless nodes, unique node IDs, and valid relationship references. And once everything is valid, it will generate a graph output JSON file. Also, the output to the visualizers. Used network X has been used to generate the PNG file through matplotlib, but it has the Python version limitations. Also, I have generated the mermaid MMD files and a HTML visualizer where this whole mermaid is been viewed in the browser. So these are the major modules. Main.py is the pipeline orchestration with iterative progress updates. Schema.py using pedantic model for node relationships knowledge graph. Input loader to load your raw text. Config for configuration management environments. Chunker for text chunking for large documents. Merger for merge and deduplicate multiple knowledge graph instances which generated through chunks. Extractor to extract the LLM using factory pattern, OpenAI, Gemini, or Llama. Validator for schema validation, auto repair, and on-fold node removal. Visualizer, network X graph construction and PNG rendering. visualizer mermaid to mermaid diagrams and interactive HTML viewer with dark themes always available. Okay. So these are the basic 3 supported providers I've used in this project: OpenAI GPT-4, Gemini 2.0 Flash 1.0 1.5 Pro, configurable by Gemini model, Ollama tested through Ollama 3 latest, and Qwen 2.5 7 billion. So defaulted to OpenAI, defaulted to Ollama. These are the environment variables. To set any of these provider, you just need to run export either through export or set these variables in the .env file and run your orchestrator. If you wanted to run from a local Ollama, just select the model and the provider and run. Qwen, if you wanted to run Qwen, Qwen is highly recommended for your structured outputs. So Ollama, Qwen, and then run your orchestrator. Same with Mistral. Through Gemini, just provide your Gemini your KPI key, model name, and run. So the recommendation from Ollama models are it is general purpose extraction for it is good, but for excellent structured JSON output and knowledge graph extraction, Qwen 2.5 7 billion is good. So if you are using local Ollama models, definitely it doesn't affect your APIs. You don't need to be at any cost because there is no rate limiting, no API cost involved. It is completely offline and deployed locally. Gemini is heavily offers a strong reasoning and large context window. So 2.0 Flash is good. This is the relationship types has been used in this project. Mainly the categorization is financial, ownership, partnership, risk, strategy, and compliance, and these are the types. Document chunking has been used to handle large documents that exceeds your LLM context windows, and we use intelligent chunking and merging concept here. So how it works is like text splitting, document split into overlapping chunks in natural boundaries, paragraph, sentences, parallel execution. Each chunk is processed independently by the LLM, and you all extracted graphs are combined into node deduplications, and then results are saved after each chunk, and browser updates that in the real time. There's a configuration have been put in the environment variables like chunk. If you wanted to enable it, you can enable it. You have to give the token size and also the overlap between chunks. These are the recommended settings have been given. If you're local using Ollama, then give chunk size to 4,000 because of your system limits. If you are using OpenAI, 32,000 is good, or 50,000 for Gemini. You can also export these settings initially through export command and then run your orchestrator or set these things into your environment file, .env file. Node deduplication, ID numbering. So these are the design decisions, mainly node deduplication, ID renumbering, semantic boundaries, overlap preservations, and continue on error. Setup is pretty simple. You need Python 3.1 plus for one of your LLM providers, Gemini LLM. Installation instructions is pretty simple. You clone this repository, go to this directory, create and activate your virtual environments to Python, and then install all the dependencies through requirement.txt file. Set up your .env file and run after setting up. So while testing, I have actually used the large documents, taken the Reliance Industries annual report and Adani annual report. I used Poplar to convert this PDF into a raw text file through PDF to text command. It gives me a raw text file, and then I have started running this Python file. So this annual reports tested these annual reports, which have 200 plus pages and contains 30,000 lines of text. The financial detective project handles large documents automatically through chunking. Expect extractions to take several minutes depending on your LLM provider. The output looks like this. These are the pipeline output. It first load and display your number of characters, then extraction knowledge graph by LLM. It shows the provider, the model name, and then starts the chunking part. Each chunks has been processing separately, and then once all nodes are done, all relationships are completed, it then validates and repair your knowledge graph. Unwanted relationship will get removed, and after complete validation, the 48 nodes 30 relationship has been passed example. This is the way, and then finally it will save your JSON file and then create your PNG, mermaid, or HTML output. Output file will be visualized in this JSON form, data graph output to JSON as per the requirement. Visuals are into graph PNG, MMD, and HTML file. Right. For network X visualization, there is a requirement requires a Python 3.1 to 3.13. 3.14 network X has an upstream compatibility issue, and PNG rendering is automatically skipped. So mermaid and HTML visualization remains fully available on all Python versions. Right. So these are the mermaid visualization patterns, like parent organization owns, has risk, reports amount. This is the type of labels are used, rendering used for this. Okay, and this is the test cases to run all my criteria tests. So I have created test cases for all modules, right? And this is for test coverage, where I have completed 185 test case written for all modules. It covers everything. Right. So this is a project structure where financial detective data has been input file, output file, and then your SRC package, and then your test package, your visuals, your docs, and then your orchestrator. So I'll now run you through the technical design document. The technical design document is I have covered that in the README file. The problem statement, okay, everything. The high level architecture I'll just explain again. This extractor has the factory .py. It will pick the LLM through environments, and the mainly the all provider, whichever I am using, it has the common prompts has been set, like unified system prompt with 18 relationship we just explained. All have an anti-hallucination instructions, JSON only output enforcements, temperature 0 for determinism, right, and JSON repair and relation normalizations. Once everything is then they'll pass the JSON response, validate against the pedantic schema, and save your results after each chunk. Knowledge graph generated and pedantic used to validate JSON according to the schema, and once everything is passed through this validator, it will check all at least one node exists. It will check all nodes are unique. It will repair, remove all unwanted relationships, like remove orphan nodes, raise a value error on critical violations, and then after everything passed, it generates a JSON through model dump JSON serialization, and then mermaid files, interactive HTML. These are the components, and mainly knowledge graph model contains these three main types: entity type, financial relationship, risk relationship, and ownership relationship has been extracted and using this relationship types. categorized mostly in 18 relationship types here. Right. Node types are company, risk factor, dollar amount. These are the examples given. Total 18 I already told. Relation for schema and design. Why pedantic 2 has been chosen? Because it has been type safety, JSON schema generation, strict mode, extra forbid to reject or unexpected fields, serialization for consistent output, and standard in fast API and modern Python tooling. Okay. Strictness as contract extra equal to forbid has been given so that it will not give you any unexpected, it will not add and introduce unexpected fields. LLM will not going to add. Fail fast, input invalid outputs are rejected immediately. And right, so I have added optional fields also, context and confidence, because a lot of times I've seen the context will not able to determine. So every node has a context, explain what the node represents if there is a context given, or example also the confidence of on relationships. So, and both fields are explicitly defined in the schema. The extra forfeit constraints still prevent any undocumented fields. These are the documented. These are the provider models. Okay, I see, already explained. So mainly the prompt which has been given to LLM is identical prompt constraints has been provided to all. It's a unified system prompt with 18 relationship types, ownership direction rules. Subsidiary cannot own parent. Example, this is rules has been given. Anti-hallucination instruction, JSON only output enforcement, temperature 0 for determinism. Context requirement for every node, JSON repair and relation normalization functions. So these are the mainly design principles for your prompt. Anti-hallucinations, do not hallucinate or infer information not explicitly stated in the text. Do not add entities or relationships that are not directly mentioned. Only extract information that is explicitly present in the provider text. JSON only output, or output JSON only JSON, matching the schema below. No explanation, no markdowns. Respond with only the JSON output, no additional text, and ownership rules and deterministic behavior. So these type of prompt design has been given to all providers before hitting LLM. Now, okay, so large document chunking ways like chunker.py takes care of your large document chunks. It creates a parallel chunks and runs chunks parallelly, extracts the graph, and then save your results, intermediate results, and graph merger will merge all your graphs and deduplicate it. Deduplication runs on it. It renumber IDs to prevent collisions and preserve schema version from the first graph, and then unified knowledge graph is being created. Chunk configurations are being separately given. Design decisions, okay, these are the mainly design decisions already explained. Okay, right. So, and this file is created to show how I have used prompts to build this project, mainly captured in this build prompt.markdown file. Created the schema using prompt like this, where every instructions is clear and clean. Created input loader, created extractor, given the requirements clearly, what to create and what not to do, right, for using cursor. So each prompt has been given to cursor. Mainly the model has been used as Cloud Opus into an agentic AI mod development. Validator package, visualizer, main orchestration, okay, test cases, configuration module, right, abstract base class for extractors, OpenAI, Olama, factory pattern. So these are my prompt file. Now I will walk you through the actual code. So let me just open cursor and try to run. This is my project, right, and I have set it up through let me just delete the old JSON file, old files. Let me run through through Gemini. Okay, I set the Gemini engine, try to run this main.py and see how it results. So immediately it browser is open with extraction in progress mode, and now it is running. Provider is Gemini, using a model Gemini 2.0 Flash. Okay, let's wait for some time. Meanwhile, so this is completed. The complete pipeline has been run. 36 nodes extraction, 37 relationships, right? Validation also passed for 36 nodes and 37 relationships. Graph.output JSON file has been stored here. Now this is the JSON file for this input text I have given is a raw input text, and this is the JSON file it creates. To run it fast, now if I refresh this whole graph has been created with this all visualization patterns like zoomer, zoom in, zoom out functionalities. It has 36 nodes and 37 relationships, and this is the graph it created, which has the relationships like relationship includes owns, has risk, reports amount, and this graph. I also tried with a bigger text like actual text, which I just explained. This report REL, which has around 13,000 lines. Also the Adani file, which has around 39,000 lines. I converted it through a tool popular, and PDF to text conversion. I used this text and generated an output using Gemini. It takes around an hour to generate, but I'll just show you that what is the output. This is the file I have used it, actual file I have used it. This is the actual file, Adani report I have used it, and it generates the output like this, right? After completion, it takes around, and it creates around 1987 nodes with 1130 relationships, and this is the whole graph it created. I'll just take, it's a very big graph with all meaningful relationships it has put, and this the graph it generates after running. I also use Quen for the same financial this text, and it generates, the Quen has generated this output. Quen takes little bit of time for 10-15 minutes to generate this, and it generates this graph after running. Right, so that's all. It has the output JSON, and the visual package, visual folder has all kind of visualize HTML and MOMAT files available. Right, so in summary, the financial detective shows how LLM combines with strict schema validations and zero regex approach can reliably transform complex financial document into unstructured, trustworthy knowledge graph. Thanks a lot.